Hello and welcome to our TI Technology webinar hosted by Texas Insurance Australia. We are excited to bring you Applications of Differential Calculus, Unit 2, Topic 4 from the QCE Mathematical Methods course with the very experienced mathematics teacher, researcher and author, Mr. David Tynan. My name is John Bayman and I am your host for this event. I teach mathematics to Year 7 to 12 students at Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. Now, before we get started, I just wanted to remind you of the QCE teacher resource books that are available on the TI Queensland website. They have been extremely popular. However, if you do not have a hard copy yet, please email the email address at the top of this PowerPoint slide, teacher-support@list.ti.com, and they will post one out to you. And also to let you know that the General Maths TRB will be available from the end of the month, so stay tuned. And as you can see, our main presenter for this evening, David, was a key lead in the creation of these resources. As a general reminder, tonight's webinar is being recorded and will be available to rewatch or share on our on-demand webinar page on the TI Australia website. Please feel free to send any questions at any time to David using the chat window on the right-hand side of the screen. And that is all the formalities done. I would now like to introduce our presenter this evening, Mr. David Tynan. Evening, David.
Evening, John.
Great to have you with us. Thank you for joining us today. David has a keen interest in the role and impact of technology in the secondary mathematics classroom. And I'm really looking forward to him sharing his knowledge and skills with us tonight. David, it's over to you.
Thanks, John. Hello, everybody. Okay, so welcome, everyone. Tonight, we will be looking at differential calculus. But before we begin, I think it's worth just reminding you where the materials for this webinar will have come from. So John thankfully mentioned the 3 teacher resource books. Obviously tonight we'll be using some materials from the Mathematical Methods TRB for the TI-nspire CXT. And what I have in front of you is a PDF. You should be able to see a PDF, and I'm scrolling up for the first couple of pages to the index, and I'll come in a minute. But on the right hand side of, I think it's just inside the first page or the cover, there's a link to the digital version of this publication. So I'm just going to show you that if you go to the actual website that it refers to, you will see the TI website for Queensland, for Inspire, and it has a number of resources, but right down on the right, you'll see Queensland ebooks, and there is a digital version. The one that we're looking at is that second one, QCE Mathematical Methods TRB. So I've just done that so that you can see that the PDF that I'm be referring to and that John said that you could get a hard copy for is also able to be downloaded as a PDF. So without further ado, let's get into the material. So it says that tonight is about Unit 2, Topic 4. We're actually going to start on Unit 2, Topic 3, which is Introduction to Differential Calculus with some rates of change, and then we'll move into 2.4 after that. So I'll just show you the pages that I'll be referring to. So I'll just change it so that it's just viewing one page. Okay, and now this is the PDF on page 36, and this initial problem about rates of change, hopefully that's big enough for you to be able to see. I might make it slightly bigger. is a simple modelling question about a water tank and the emptying of the tank through a tap, and the volume at T can be modelled by that function. V of T is 20 minus T all cubed, and it lasts for 20 minutes. So T is in minutes. So the rest of the instructions here are essentially, you would be able to follow those, but I'm going to do it on the calculator live so that we can make some comments about that. So I'll go to the calculator emulator. So I'm going to try to do this reasonably slowly and slow enough so that if you're wanting to do it at the same time as me, that you will be able to do that. Let's first define the function. So that's V brackets T, and we press Control and then the T. You'll notice it goes red, and above that has colon equals, which is we are going to assign to a function V of T, and the rule is brackets 20 minus T cubed. And we're also going to put a domain restriction on it. So if I press the Control key and the equals key, I can get this vertical line, which is a condition key. So I've now put in that vertical line. So I'm saying the rule is 20 minus T all cubed, with the restriction that that T is only between 0 and 20 inclusive. So 0, then Control equals to get the less than or equal to. Press the letter T, Control equals, and then 20. And the calculator is happy. It says, okay, I'm happy with that definition. So let's do a quick check to see if it's behaving. So if I do V of 0, notice that the V is now bolded. That's the calculator's way of saying that's defined for V. So V of 0 should allow us to just substitute 0 into that rule. And we see that the initial value of the volume is 8,000. So it is an 8,000 litre tank. And at 20, so if I do V of 20, so presumably it is empty at 20 after 20 minutes, according to the model, and that's what it's showing us there. So before getting into a little bit of the calculus side of it, we're just going to try to construct a picture. So notice that I've defined the function in terms of time, T for time. Now we're going to try to construct a helpful graph that lets us look at the rate of change of the water as it leaves the tank through the tap. So in order to do that, I have to add a graph. Now, there's more than one way to do it, but probably the easiest way at this stage is just to press Control and I for insert, and that allows us to add a page. And I want to choose page type 2, which is for graphs. So it's wanting me to define to tell a function to graph, and I'm going to do V, but I can't do V of T, but I can just put V of X. So there's no with that sort of definition. Now, if I press enter, you'll see that nothing much is visible, but that's unsurprising because we're talking about something where the horizontal axis goes from 0 to 20, and the volume starts at 8,000 and goes down to 0. So it won't be very visible here. So there's a number of ways to adjust the window settings, and we'll just choose one particular way. So in order to adjust the window settings, if I press menu window, zoom, and choose window settings, I'm going to make the X, or if you like time, I'm going to make it 0 to 20, and the X scale, or the markings on the horizontal axis, will be every 2 minutes. Now, I'm going to press OK. I'm not going to adjust the Y min and the Y for reasons that will become clear in a second. So I can see a little bit of the graph on the right there, but I'm still a long way away from 8,000. So many of you will know this step, but if you do menu, window zoom, and then zoom fit, what that will do is we'll modify the Y min and the Y max so that for the X values that you've chosen, that is from X min to X max, that it will display the graph if it can. So here's zoom fit. So that gives me a much nicer picture. And you'll see that the top is at 8,800. Now, I'm still not happy entirely with that. So I'm going to change a couple of things. I'm going to go to the menu and go to view. And for the grid, I'm going to choose a lined grid. So that will be helpful. The next thing I'm going to do is to make it so that I can see the markings on the axes. But instead of having the vertical one go every 500 litres, if I click in there, I'll change that to 1,000. So it goes up in 1,000 litres. Now, unfortunately, I get to see the boundaries of the window, but I don't really get to see the numbers on the other scale marks. But I can do that. So if I hover the cursor over the tick marks on the axes, it says axes. And like with computer software, where right click gives you context sensitive help, you can do a on your calculator. Now it's control and then menu. So control menu, while I'm hovering over the axes, gives a pop-up context sensitive set of operations, and I want to choose the attributes. So I'm interested in the attributes of the axes. So if I select that, another pop-up menu comes up, and I'm not interested in changing the arrows on the end, so I'll press the down arrow. I'm not interested in changing the zoom setting. If I go to the next one, that's what I'm interested in, the tick labels. So if I'm on that option, if I go to number 1, you'll see it says multiple labels, and that's actually what I want. Now, in order to make that executed or the current setting, I have to press the enter key. So by doing that, and now I have nicer markings. Still not entirely happy. So there's 2 things I'm not happy with. I would prefer that the volume, the vertical axis, I would prefer that the tick marks are on the other side, to the left of that axis. And also, I would prefer that on the horizontal axis, the time, I would prefer that I could see 20. So I'm just going to make a couple of small changes. So if I press menu, window, and window settings, I'm going to make the X-min start at -2. And I'm going to make it go as far as 22. And let's see how that goes. And I might just, this is effectively 1,000, but I'll just make that a bit clearer. Okay, so I'm much happier with that.
David,
but now I've got yes.
And it's really nice to see that obviously those pages are linked together. So that's the reason why you could just put in VX, and that V went bold as well, isn't it?
That's right. So when you, unlike the TI-83 and 84 and other calculators, the Nspire uses a document model, and you're able to have different applications on different pages. However, if it's 1.1, 1.2, 1.3, anything that's defined in one of those pages is similarly defined in the other pages. So as John's saying, in definition, I can make sure that V of X is understood in the graphing pages. Now, this is probably also a good reminder to show that there are some defaults that you might be interested in. So all calculators have some sort of settings menu. So the Nspire has the settings menu and also has settings that are just particular to each app, like the graph app or the calculator app. So I'll just show you while we've got the graph showing. If I press menu, you'll at the bottom here, there's settings. These are the settings just for the graphs. And there's some things that I do. I mean, it's your own choice, but I always like to have the lined grid showing as a default. So that's one default I like to have. The second default that I have is that it automatically hides the plot labels. So the reason for that is if I have a lot of graphs that I'm showing, I don't necessarily want to see the labels for the graph, you know, what is, unless I select that graph. So I'll put that option back on. And the only other thing that's quite helpful to be clear about is the display digits. So this is if you have coordinates being displayed or equations being displayed, you can set how many, I guess, significant figures is probably a reasonable way of doing it, that are displayed. That's able to be set as a default as well. Okay, so let's go back to the graph, and just to stress that point about the label, you'll notice the label for that the graph that's showing is not visible, but if I hover the cursor over it, it does show up. So we've done reasonably well. We've got a nice graph. We can see that the story of emptying this tank seems to be that the gradient is much steeper at the start than it is at the finish. Just talking in a sort of qualitative way, I guess we would just ask our students about that. But the questions that lead into the calculus might be to consider, well, what if we're interested on what the rate of change is of the volume in litres per minute is at 10 minutes. So the typical way that we introduce this in Unit 2 is to, with our students, start talking about the average rate of change. Now, we're going to look at what's happening in the first 10 minutes on average and what's happening in the second 10 minutes on average. But we're going to do that by just some calculations. So I'm going to go back to the calculator page. You can just hover over 1.1 and click, and it will go to that page. You can also do Control and then the left arrow, and it will jump back to that page as well. So now let's get to the point. We're interested in what average rate of change in the first 10 minutes. So a way of guessing that is just to find the, I guess, the rise over the run. For V of initially, we would find V of 10 minus V of 0 over 10 minus 0. So I'll do a fraction, so Control, divide. And if I do V of 10 minus V of 0, now it's not necessary to write it completely the way I'm doing it, but just for the pattern, I'm writing it that way. So that result tells me that in the first 10 minutes, it is on average losing 700 litres a minute. Now, I'll just press the up arrow and the up arrow again and edit that expression and change it. So now I'm interested in from 20 to 10, or if you like, from 10 to 20. So that tells me that in the second 10-minute period, it's losing water at a much slower rate. On average, in that second lot of 10 minutes, it's losing about 100 litres a minute on average. Now, that's pretty crude. If we're trying to get an estimate of what's happening around 10 minutes, in our pre-calculus way, we'd say, well, let's choose something a bit closer. So we could just say, okay, let's pick this one, but instead of between 10 and 0, let's do it between 10 and 9. So that tells me that between the 9th and the 10th minute, it's losing about 331 litres a minute. And then if I change this and just do 1 minute past the 10-minute period, I'll make it 11 minutes. And that says that it's losing it at about 200, so a little bit less. And if I wanted to, I could find the average of those, or the mean. Now, in the syntax for doing mean, you're finding the mean of a list. So just to show that step, if I press Control and then close bracket, I get the braces, and I can choose to just put the mean in there. But I can also do this. And that's not bad. That's sort of saying, look, if I just found the mean of those two rates, then it's about 300. And that's not too bad an estimate. So let's see if we can get slightly better. Let's not just do to the left and the right. Let's just pick one of those. So I'm going to choose this one. So rather than call it 11, I'll just generalize slightly. I'm going to call it 10 plus some very small value h. And down the bottom, this is not 11 now, it's 10 plus h. And just at the end of that, I'm going to do a condition, that is, given the instance where I'll first just do where h equals 1. And if we've done this correctly, it should give us the answer minus 271, which it does. But if we want to get really close to 10, it would be good if we chose a h value that was pretty small. So let's choose 0.1. It's getting smaller. I'm going to add 4 zeros and a 1, so very close to 10. Now, what that's saying is, you'll notice here, it considers that that is 1 by 10 to the minus 5, so a very small positive value. And it's saying that if I chose a h value that small, then I would end up with minus 300 approximately. Now, just to show you what that really is, if I press enter, you'll see that at the limit of its display precision, it's saying, look, it is actually closer to minus 299.997 litres per minute, near there. But in fact, it's virtually 300. Now, there's no need for us to go further. This is just to show the idea that about how we work with the students to talk about average rate of change, leading on to the idea of the instantaneous rate of change. Okay, so I think that that's not a bad segue now back to the graph. So is there a way that we can do a similar thing visually? And that's what we're about to do. So if you're following along and you want to do it yourself, so if you do Control right, we get back to the graph. And now what we're going to do is we're going to draw a line through 2 points. So I'll just do this a little bit slowly. So if I press Menu, Geometry, Points and Lines, and Point On. If I do a point on, and I'll just position it here. So it's saying, where do you want to point it on? I want to point it on, I point on the graph. So if I click there, that'll do. And I click again to confirm. And I'm going to click another point just down here. Okay. So I've got my 2 points. Now I don't want to put any more points. So when you're doing the geometry tools, you have to stop. When you finish using the geometry tool, you have to stop it. So you'll notice there's down here and there's an icon, point on. So if I press the escape key, it will jump out of that tool. Okay, now I'm going to move these points, these labels. So all I'm doing is hovering over the text and pressing the button in the middle and then dragging it. Now those points
And David,
yes.
It's really nice how you're explaining it both how a teacher would do it using a mouse and equally how a student would do it if they weren't using the software and they had to use the handhelds. So it's really nice clarity. You're saying that with the handheld, obviously on the mouse it's easy, but you'd use Control and then the center of that touchpad. Is that what you're saying?
Yes, that's right. It's actually good to raise this too, John, because there are some things that are, particularly geometry tools, that are quite straightforward to use on the computer software version of Nspire. They are a little bit, sometimes a lot more fiddly to do on the calculator. Students do use it, but it is certainly a little bit more fiddly with a small screen and procedures that are a little bit less intuitive. Okay, so we'll move on, but I'll try to be conscious of the differences between the calculator way of doing it and what it would be like on the software. Okay, so here's an example. I've got my 2 points, but what I would really like is to have 1 point at 5. So if I hover over this text here and that button in the middle of the direction arrows, if I press on that and press on it again, you'll notice it goes blue. And if I type the number 5 and press enter, it jumps, the point jumps to the point on the curve where t equals 5. Actually, I probably should also show, this again is mainly for the teacher. If I did the same thing up here where it says y, I can call that volume. And I can do that. Even though we're using F1 and X, I can, for the point of view of the labeling, I can call this, so I'll call it time in minutes. Okay, so now I've got that. Now let's do the second point. I'll hover over that and I'll call that 10 and enter. And so it jumps to the curve where t is 10 or the time is 10. And at that stage, when the time is 10, there is only 1,000 litres left. All right, now time to do a little bit more geometry. We're going to do a line that goes through those 2 points. So menu, geometry, points and lines, line. And I'm going to click here. Whoops, no, I didn't mean to do that. Let me do an undo. Luckily, you can do that. Control, escape. Okay, now let's try again. I beg your pardon. I think I just clicked the thing. So for the line, click, click. That's it. Now I have my line. Now, this is another good example, as John was referring to. If I get out of that geometry tool, I'll press the escape key. It's no longer in a line drawing mode. Now, this bit is fiddly on the calculator, but what I want to do is extend the line a little bit. So it hovers over the left end near time is 4 minutes, and I'm saying line. So if I hold the button down in the middle and drag it, I can make it go a little bit further. Now, this is for the teacher, not for the student, but you might like to make this line not as strong. So one way to do that is to hover over the line and do Control menu and attributes. And with the attributes, these are the attributes for the line. So you can make it thicker, thinner, but I'd like to make it so that it's a dashed line. Again, in order to keep that option, I have to press enter. So now I have that. Just for fun, let's change the color of it as well. So I right click on it or control menu, and I'm going to make the line color red. Okay, so I've got, if you like, a secant or a chord. And what I'm going to do now is I'm going to find the gradient of that. So if I press menu, geometry, measurement, and slope, and choose the line, if I just click on it, and I've pressed escape to get out of that tool. And now that's telling me in the current scenario, the gradient is minus 475. So the rate is minus 475 between t equals 5 and t equals 10. Now that's live. So I'm going to leave the 10,000 point, but I'm going to drag this point. So if I hold the mouse button or the cursor over it, and if I drag this out, you'll see that the rate is increasing, but now I'm going to move the point in the other direction towards. And what we're trying to do for kids to see via calculator methods and then via graphic methods, that what we're doing is getting 2 points so close to each other that it's effectively the gradient of the tangent. Now, it's also possible, luckily, to just change this point. So I can just call that point x time equals 10, and you'll see then that the rate is exactly minus 300. So that's just in the introduction to calculus. That's a nice way of getting the kids used to how we move towards the differential calculator technique, calculus techniques.
And David, obviously, there's other software or other programs that you can do to show this as well. But the really nice thing about using the TI-nspire is it's also upskilling the kids for when they have to be doing it in class or when they have to do tests or in their exam. They're upskilling how to use that technology and be better prepared.
Yes, that's true. I probably should say that there really are, this is from my own teaching experience using the nspire, there are some things for which the real value is in the teacher with an interactive or a data projector, whatever's displaying the teacher software, that it's really best for the teacher to demonstrate and to ask the important questions for learning. Not so much that the student does all of these things by themselves on their calculator. There are obviously many things that is true for, but there are some instances where it's really best just for the teacher to construct the files and the teacher to demonstrate and to ask the key questions. Anyway, so that's probably enough for that. So
someone's just asked,
yes,
how if you want to use that file, with another class or save it for next year, how do you actually save that document so you can use it again?
Yeah, that's a good question. So, yeah, definitely that happens. That when you make something that you a bit of effort to do it, and you got the window right and the layout the way you want it, and you might just want to quickly open and demonstrate something rather than having the students watch you labor through constructing it. So this is a file. So the Nspire is based on a document model. So there is a document created. You'll see at the top of the screen here, it's called Diffcalc. So I've got a file that's saved. So if I do Control and S, that will pretty much save like you're saving a Microsoft Word file. And so there's a file called Diffcalc, and just for fun, let's have a little look. I'll hide that, and I'll hide this, and for the webinar, I don't know if you can see that, here's a folder which has the file. So the one we're working on at the moment is called diffcalc.tns, and that's just a file like any other file. Will be opened by the TI-nspire software. So I hope that helps with that. I should also say that there are other advantages to the teacher software. For example, this is in emulator mode, so the screen is showing you what the kids see in terms of the aspect ratio, the pixels and things like that. But it is possible for you to get a higher resolution of the same thing. So it's a bit hard to see, but on the top right of my software, there's an option where it says document preview. So if I'm at the moment on handheld, but if I change it to computer, you'll see that I've got a slightly different view. I've got more pixels to deal with, and it's just a view. So I might return to that point a little bit later when we're looking at something else for which that's the extra resolution would be valuable. Okay, so we might move on to building a tangent and a normal calculator. Now, this is a new one. So I'm purposely trying to do all of this in the one file. So I'm going to use Control-I and make a new page. And this time I'm going to add a notes page. And the reason that I'm doing this is actually taken from page 37 of the book. I don't think I need to show it to you, but I'm adding a notes page. So you may have heard or seen things before, but what we're doing is making something that does some maths and quickly calculates values related to tangents and normals. So it's a notepad in that I can just type in tangents and normals. You're able to, on the teacher software, it's much easier to do this. You can say, I would prefer that this text is bold and I want it to be red. And it'll become clear why I've done that in a minute, hopefully. So now what I'm going to do is put some maths objects here. Now, in order to do that, I've got to insert a maths box. So if the menu command here allows me to insert for the notes pages a maths box, so I can do live maths in here. Now, they're going to come across as red because I chose that, so I might just change that back. There, that's better. All right, so now what I want to do is just define a function. So f of x, and I'll do control and then the template key, and I'm going to type in function which is the same one as the one before initially. So 20 minus x. Now I should make a point about this. Before we called it v of x. Now we make something which is generalizable across other functions. So I'm just calling this or defining it as f of x. So I'd also like to find out, what is the x value. So I'm going to define something called xval, and if I do control template and xval, I'll say initially it's 10, and yval that goes with that, I'll just do colon equals because I'm on the computer keyboard, and I'll call that f of whatever the xval is. So it's just going to substitute the current value of xval into the function that's defined in f of x. And when I press enter, it executes it. So we're familiar with that point anyway. So now what I'd like to do is to find the gradient of the tangent. Now, I could use my estimate that was based on the average rate of change where the points are close, but just to do a bit more calculus, I'm going to insert a template which allows me to find the steepness of the curve using the calculus derivative. So if I press, I'm going to call this m tang, and by that I mean I want the m value or the steepness of the tangent. And the m of tang, if I press control template, and now if I just press the template key, I'll get these options, and the one that I want is that one for the first derivative. So dx of f of x, and I have to go outside of the second bracket, and I have to say where the x, sorry, I have to do my condition key. So control equals to get the vertical line, and then say where x is known to equal the current value of xval. And this should give us something that's familiar as well. We did that before. So that is the gradient of the tangent for the function defined at x is 10. Now, we can find also the y-intercept of the tangent this way. So we'll call it c-tang. So the c value of the tangent, and I'll do control template to get the colon equals for assignment. And now what I'm going to do is say, well, it's just yval minus m tang times the xval, just using the c equals y minus mx. And so that will tell me that the c value will be at 4,000. Now I can do a similar thing for the norm, say the gradient m norm colon equals, it's -1 over m tang. And the c norm is equal to, it should be y val minus m norm times x val, because it's the same point. It's just that the gradient is the negative reciprocal of the tangent. So notice that it gives you a fraction. That's because it's defaulting to giving the answer in that fractional form if it can, rational form if it can. Now, I've got two options here. I can do Control Enter, which gives me the approximate value. Or there is another way. If I'm inside the maths box, you see inside and you see the red dots around it, and I press Menu, Math Box Options, Maths Box Attributes, and you can say that you want it to be in a certain form. So it could be that a float form, or you might say I want it in 2 decimal places or something, and it will also do that. Beg your pardon. Okay, so is this good enough for another function? So we can quickly do that. If we just go up to the rule here and get rid of that rule for f of x and put in another rule, 0.1 x times x minus 4 times x plus 4. And so it automatically will recalculate for the values that we've chosen, the values for the tangent equation and the normal equation. So I'll just change the x val to 3, and then it recalculates again to find it at that value. So that's telling me that at x is 3, y is minus 2.1, and the tangent equation is 1.1 x minus 5.4. Okay, so let's see what that looks like. So we're going to insert, so I'll just do Control I, and we're now on the 4th page, and it's also a graphs page. So just to make this clear, we've got 2 graphs page now, and we have already defined something, the original volume function in F1. So it's giving us the option for F2. Notice F1 is the graph that was in F1, that is V of X, is not showing, but that's okay. We don't want it to show here. This is a different story. We could have a second document, a new document. We could do a new problem, but I'm just, for the sake of this webinar, just going to go all within the same document. So F2 of X is, we've defined it as f of X. So we can just type that. And so now I get that cubic, and I'm interested in finding the gradient of the tangent. Now we know that you can just draw the tangent, and you could on the 83, 84. So let's have a little look at the inbuilt one. So Menu, Geometry, Points and Lines, and we want tangent. And I'll just click anywhere on there and click again, and it gives me the graph of the line of the tangent. Now, if you want to, this again is fiddly on the calculator, but not on the software. If I'm hovering, let's say here, you'll notice it says graph F2. If I press the tab key, it will move around, and what I really want is it to be on the line, and I can then drag that out. That is hard to do on the calculator, but pretty easy there. The next thing I'd like to do is I'll put the tangent equation down there, and on the point, what I would like to do is show the actual coordinates. So if I press Menu, View, Menu Actions, Coordinates and Equations, that allows me to display things. So I want to display that point. So if I click on that, I've got it showing now. Okay, I'll get out of that. So that point there, and now I'm going to get out of that mode and make that the point. I think I made it 3, x is 3. So there's the point, and there's the tangent. And the next thing I'm going to do is do a name of the curve. I can't do the normal equation here, but I can represent it by doing a little bit of geometry. So if I do menu, geometry, construction, perpendicular, and if I click on the line and then on that point, it will construct a perpendicular. So if I press escape, that's gone now. And this is dynamic, so I'm able to move this around to see the two curves. See the tangent and the normal being displayed. Okay, it's probably a good time to move on slightly. So we might jump a couple of things and go to some other calculus type features. I'm going to remove the tangent. So if I press right, control menu and press hide, and that hide, and the line, which is the tangent, I'm going to hide that as well. And this point, I think I can just hide that too. Yep. And I don't need to see that. Hide. Okay, now what I'd like to do is just to show what you can do with the trace key. So menu, trace, graph trace. Now we know some things about the curve with the trace key. It has this magnetize feature. So if I hover with a trace cursor and it will jump to what it thinks the maximum is. And it will display down the bottom the coordinates to the display precision that I've set. So this might be different on your calculator, but if I do menu settings, you'll see I'm on float 4. So just for interest's sake, if I change it to float 3 and OK, you'll see that the display precision changes. Now, the kids have to know that sometimes the display precision may round the numbers to an unacceptable precision for the answer required. So they just need to be careful about that. It will also, of course, with the trace, it will pick up zeros. One interesting thing with the Nspire, which I don't think was on the 83 or 84, is if I chose to, I'm interested in jumping to the curve when x is 10. I can just type 10 and press enter, and it may make a very unusual window, but it's trying to get that point to be showing. So it's done that quite successfully. However, once you've finished at x is 10 and y is 84, you may wish just to go back. And the beauty of the Nspire across the entire family is that it has multiple undos. It is my favorite feature of the calculators. So if I do Control Z or Control Escape, it will go back. And if I've done a number of things that I wish to undo, I could have actually used it to undo all those geometry objects as well. So yeah, so that's a nice feature. It's also nice, just being aware of the time, I'd like to add a graph which is the derivative of this graph. So this is a cubic. So if I press the tab key, it jumps and allows me to define a new rule. So I'm going to use the shortcut for doing the derivative, which is Shift minus, but you can also get it from the template key. So I'm going to say d dx of the thing that I put in f2 of x. And now this should draw the derivative. And that's really nice to see at the same time as the original function graph. And I can even do, and this is steering into sort of year 12 methods, but just for the sake of it, if I press tab again, or Control G also does this. And this time I will use the templates menu. So if I do control, sorry, not control, just the templates key, you'll see there's the second derivative key there next to it, template. So I want d squared dx squared of the function that I did put in f2 of x. So that is unsurprisingly a straight line. But I did also want to, I'll get rid of this. I don't really want to see this. Okay. If you press menu, trace all, you'll see that it displays the rules on the left, and on the right, down the bottom right, it just displays the current coordinates. So there are some important things that we can discuss with the kids here. What is it about the points where what's happening at the turning points? So if we press the arrows right, you can see that there's something happening there. It looks like the derivative is 0, and it looks like the second derivative is positive. And compare that to a point over here where the curve, the red curve seems to be, in fact, there's even a nicer way to do that. If I just press there, it should jump to the minimum, does it? Maybe not for the precision I've got. I'll change my things back to float 4. Okay. See if I can get it to jump. Okay. Anyway, the point is it allows you to compare the values of the function and the derivative of the function and the derivative of the derivative of the function. Earlier on, I said, be careful. You are able to, with the computer software, you can choose to see that with a bit better resolution. So this is allowing you to, I'll just make that a little bit smaller. So that gives you more pixels to work with, and it's a little bit easier to represent all the things at once. Now, before we go, I'll just change back to that mode. I'll just go to a calculator page, and we won't do it. So if I go back to the original page here, there are a couple of other calculator features related to calculus. So you can find the stationary points by doing derivatives at a point and using nsolve. And you can also find the absolute maximum in a given domain. And it's just a feature of the calculator command there. Now, run out of time to show a couple more things, but all of the things that I have mentioned today are things that are in the teacher resource book. So I'll just finish by showing that. So if I press a home key, yep. So you'll see here that there is a lot more calculus stuff to do. So stuff that relates to Unit 3, and obviously some integral stuff for Unit 4 as well. But I think it's nearly up. So I think if that's all right, John, I might get you to take over, and thank you very much, everyone.
David, thank you so much for such an informative webinar. I always think your study pace and also the clarity of your explanations always impresses me, I have to say. And I think, for example, the detail that you like to show in graphs and how to do it. And like you said, everyone's favorite, the undo feature, but you really have just scratched the surface. I always learn a few tips from you. So David, thank you very much for sharing that tonight.
You're welcome.
So as we start wrapping up, just a reminder that our dedicated Queensland TI education page can be found at education.ti.com/Oz/QLD. And as David showed, if you scroll to the bottom of the page, you'll find the downloadable teacher resource ebooks, like what David was using today. We're going to begin wrapping things up. So if you do have any last minute questions, please try and get those asked, as I know David will endeavour to check the chat window and answer them or add them to future planning of future webinars. And when you leave the webinar tonight, a brief 4-question survey will automatically appear in your browser. Your feedback guides us as we plan future online events. We listen to your feedback, and so we hope you share your thoughts in a post-webinar survey. And if you're watching live in the next 24 hours, you will be emailed a link to the past PD events. I also encourage you all to check out our student, or teacher for that matter, online courses and our very own TI dedicated YouTube channel. And sadly, that brings us to the end of our webinar. Thank you to David for everything you've shared with us tonight. I've really appreciated it, and I know from the comments in the chat that our viewers have too. So thank you, David. And equally, thank you everyone for joining us tonight. We hope to see you back online soon, and enjoy the rest of your day. Take care. Stay safe.
Thanks. Thank you. Good night, everyone.